So I thought, because our session 5, which obviously is going to be a number of weeks' time, is about 3D scanning and a bit of software called Mesh Mixer, I'd really like us to think now about an object that we could get to the Fab Lab to be 3D scanned, and then the file could be sent back to you in preparation for the start of session 5. So you've actually got something that's been scanned. Now, you don't have to do this, but I'd just like to give you the opportunity to do it. So for instance, the scanner itself is just a handheld machine, and I could just basically move around a face, for instance, or an object. And then what we get is a file, a CAD file, it's a mesh actually, which can then be sent to a 3D printer. We can also do wonderful things with that in a bit of software called Mesh Mixer, where we can actually take the head off and put another head on. We could almost like 3D collage. So there's lots to think about. So what I'd like you to do, and we'll be setting this not as homework as such, but I'd like you to think about something, ideally about fist size, an object that you could either send to us or you could suggest as an object that could be 3D printed for you. Because later on in this session, we're going to have a quick look at a bit of software, or a little bit of a resource, I should say, called Thingiverse. And in Thingiverse, there's lots and lots of objects that we can download. In fact, we'll be doing that in this session. So have a think about an object that you might want to have 3D scanned. If you're not local to Plymouth, perhaps you could post it to us if it's not that expensive. Or if it's a fruit or something like that, you could just suggest an object and we could scan it for you. And hopefully we'll all have something to play with when it comes to session 5, 3D scanning. So enough of that. Let's go now to a quick recap on Fusion. I'll hide that and I'll go on to Fusion 360. So Owen, if you wouldn't mind fielding the questions from chat, and please don't hesitate to stop me as we go along. So hopefully you should see a blank page now. Just opened Fusion, is that correct?
It's correct. There's a question from Laura. Do the files you make on Fusion 360 work on any 3D printer?
Yes, in actual fact, because we've got, as I said, we've got CAD CAM. CAD is Fusion 360, what we design. CAM is the machine. And in the middle is a bit of software, as I said, called Cura. What Cura will do is it will take the file that we save from Fusion, and it will do all the translating to go to any 3D printer. So as long as we save it in a particular format, and that's generally STL, as Owen said last week, stands for stereolithography. It's quite a big word. I don't even know what it means, but STL is a kind of 3D JPEG, which will open in anything. There's another very popular file format as well, called OBJ. So either STL or OBJ, whatever we save from Fusion, will go to any 3D printer. So I'm just going to kind of recap. If there's any more questions, please shout them out. I'm just going to kind of...
Darren Lee is asking, I have a tabletop milling machine. Can the files convert to that? Maybe I should answer that one.
Please do.
It depends on the interface with that milling machine. Often milling machines will come with their own piece of control software, and you need to be able to import certain file types to that bit of software. And they would generally be either in the form of a .stl file format, same as 3D printing. They might be in another file format, maybe .iges. But if there's any doubt, you can email me and I can check it out. I'll just post my email address, and I can inquire for you, if that helps.
Cool. I say Owen is an expert in milling, I have to say. I tend to think as long as it's an STL, it'll be fine, but you have to design it in such a way that it could either be 3D printed or perhaps it would be better to be milled. And I say Owen has a lot more experience than I do on that. But if we just stick to the idea, the general idea that if we output as an STL from Fusion, you can't really go wrong, because there's lots of other programs where you can take your STL file and convert it in a slightly different file. So Rhino is another CAD system that we use. It's got a whole host of file types that we can convert to. So generally, we're going to stick to STL for 3D and DXF for 2D as our formats. So I'm just going to go to Sketch at the moment, and we've got the 3 planes here we can choose from. And as I'm just going to draw a quick shape, I'm just going to go to the bottom one here, and I can make any shape I like there. So I'm just going to do say a rectangle from the center. So I've got the center there, and I've got my 2 tabs that are live now, and I can type in 100, and that set the bottom one to 100. If I want the top to be 100, I can press tab and it will go on to the other one. Press 100 again, and I can just hit OK. I can do a circle as well into the center there, any size really. It will make that 70, and I'll hit OK again. And now I can stop my sketch. And so the quickest and easiest way of making a shape is to just select it and then go to the Create tab here. And there's a shortcut here, Extrude, but it's also here on our drop-down menu, Extrude, which is down here. And we can just click that and drag. And because I've only clicked the outside part, we can drag that up now into a solid form. And of course, when we come down here, we can click New Body. And there we have it. There's a simple form. Similarly, we could go to our bodies on the left-hand side here, which I always think of as like a filing cabinet, and we can turn that on and off. Body 1. And I'll draw a new sketch, I think. So I'll go to Create Sketch. And this time, I'll look around the box here, and I kind of like the idea of looking where the front is there. So I'll select this as my sketch, the front. And I'm just going to draw a quick shape which will revolve, which was one of the other quick ways of producing shapes. I'll draw a couple of lines first, one at the bottom going up. You can make that 100. I can come out at the top here, another line, and we'll make that 25. I can carry on, can't I? You can see if I could just left click, it will just keep doing lines. You can't quite see it, but somewhere here, if I scroll out, you'll see a tick. I want to finish my line, so I'm just going to hover over that little green tick and left click on that. I'll draw another line at the bottom, like so. Another tick there, and I can make a wiggly line between them. We can go to Spline, which is our curve, if you remember. I'm going to go to Fixed Point Spline, what we're saying here, and I'll just do a couple of clicks there. Take that down to the bottom and click OK. And as you can see, it goes blue in the middle there, so I can finish my sketch. And because it's gone light blue there, I know that's an enclosed line, so that's a surface that I can then either extrude one way or the other, or I can revolve around. So let's just do a quick revolve on it. I'm going to go to the Create menu, and of course there's an icon on the top that says Revolve, but just in case you haven't got that, as we drop down the menu, we can go down to Revolve, the second one below, Extrude there. Left click on that. And now it's asking us what the axis is, because I've already got the plane highlighted. And the axis is down here. So the profile itself is this one here. And then we go to the axis. We go to the drop-down menu here. And when it says select, I'm going to left click on that. And then I've got the ability to choose which axis I'm going to revolve around. So of course, if I wanted to, I could revolve around here. But I don't necessarily want to do that. I'm going to cancel that actually and do it again. Go to Create, go to Revolve, exactly the same thing. This is my profile here. The axis this time, instead of this one, will be the Z with the height, which is the blue one coming up here. Left click on that and it goes all the way around. And click OK, and there's our form quite quickly and easily. And if you want to modify that, if you want to change that, if you remember to hollow it or to put edges on, round edges on, it'll be under Modify over here. So I'll go down now here and I'll just shell that. Shell means hollow, and it's asking which face to select. That's on that menu there, so I'm going to select the top one, left click on that, and I'm going to choose 2. That's a 2mm. And that's a little bit thick, so I'll take that back and put 1. And there you have it. I'm just going to click OK to accept that, and I've got an object. Okay, so I'm hoping that after last week, you've all got an object, a 3-dimensional object that we can save to take forward to take to a 3D printer. So I'm just going to go over again, I think it was covered last week, but I'm just going to come over and just explain how this object can be saved in the correct format to go to a printer. So let's have a look on the left-hand side here. I've got 2 bodies, if you remember. I've got the first one here, which was our extrude. I'm going to turn that off. And I've got a second one here, which is my vessel. And of course, we can actually highlight over the word body 2 there, left-click once, left-click the second time, and I'll just call that vessel. A good idea to start getting used to that so that we know which one's which, basically, as things get more complicated. So I'm going to highlight that vessel now and right-click on it now with a PC. I think with a Mac, I'm not quite sure how you do that. But if we can get to the point where we can do the equivalent of a right-click, we can go down to Save as STL. And notice at this point, it doesn't give you any option but to save as STL, the stereolithography file that we mentioned. So I'm going to left-click on that. And then a drop-down menu box will appear. Here it is on the side here. And the format is binary. I think there's 2 to choose from, but we'll keep it as binary. And the other thing to watch out for is the refinement here. At the moment it's set to high. If you have a medium or a low, you won't get a good finish. You'll get kind of almost like surfaces around the curve that you want. So make sure that's on high refinement. And then we can click OK. What will happen then, it will ask you where to put the file. Now, just for ease for today, I'm going to put it onto my desktop. I'm going to call that vessel, which is correct. And it's also making sure it's still STL files there, going onto the desktop. I am dyslexic, so I have to make sure I'm putting it in the right place. If I don't double check everything, I have no idea where I'm putting it. So I'm just going to hit save. I'll wait for that to finish, and there we have it. Okay, so can I just ask at this stage, have we all got a STL file that we can take into Cura? If I don't hear anything, I'll carry on, but just shout me if you want me to stop. I'm just going to check to see if my file is on the desktop. And I can see vessel just here, which is perfect. The reason I've gone to the desktop is if you don't know where Cura is and you've got it on your machine, I just go down to the bottom left here, type to search, and I'm just going to write in Cura. And here we go. There's Cura. I'm going to click on it. Now, it might take some time to open up. And what I normally do at this stage is turn my internet off, which speeds it up massively, but of course I'll lose you if I do that. So we're just going to wait for that to open up. And here we have Cura, which is open. Would you like to do the same and just make sure we have Cura open? I'm going to leave it a second just in case there's a problem. Now the first thing we're going to do is to decide which actual machine we're going to be using.
Sorry, Ian, can I just interject? There was a yes for that question. I just had my mic off, so.
Did somebody want just a bit of time to open that up?
I believe so.
Okay.
So when Cura is asking for a printer, one that you can select would be an Ultimaker extended to any Ultimaker printer we have.
Yeah.
If it's asking for one that is on like a wireless network, then obviously you can't add that. But it will always ask for a basic printer.
Yeah. The Ultimaker 2 extended should be absolutely fine, shouldn't it?
Absolutely.
Because that's our kind of go-to machine. At the moment, this is an Ultimaker 3, as you can see, but I'm going to change that to the Ultimaker 2 extended. You'll see just a slight change. And this is a virtual representation of a 3D printer. Now we've also got this Ultimaker 2 Go. I'm just going to have a look as we're waiting to see if that's actually on a list somewhere that I can add. And we've got Add Printer down here. So I'm just going to left click on that. Non-network printer. And have a look at this huge list. And there it is, Ultimaker 2 Go. And it's a kind of tiny little thing that I used for many years. I haven't used it for quite some time. So I'm just going to click that one as well. I'm going to add that. Just click on Add. And now in my drop-down menu, I've got my Ultimaker 2 Go, which you can see is tiny in comparison. Or I can go back to the Ultimaker 2 Extended Plus, which is our standard machine. Just going to leave that for a second to make sure we've all got that. That's great. I think what we'll do is we'll stick with the Ultimaker 2 Extended because that's the kind of size of object. I would like everybody to have the chance at the end of this session to have your work 3D printed or to have an object laser cut and assembled into a form. That's not going to happen very quickly. Because I'm just going to ask a quick question. Some of you may know the answer to this. How long do you think it took? Hopefully you can see this little fella. How long do you think it took to print this, to 3D print it? I'm going to put that out to everybody to, you can either type your answer in or you could just shout out.
Laura says 3 hour question mark. Darren Lee suggests 2. Gareth Evans says 6.
Okay, good.
4 hours, 2
Good
hours,
guess.
5 hours.
Yeah, I'd say 5 to 6 hours, wouldn't you, Owen?
Yeah, about that. Yeah,
about that for this particular model. So it's not actually that that fast when you think about it. It takes some time. So to get all of us, I don't know how many are actually online at the moment and how many we've got on the course, but I think we've got about 14 or 15 on the course. That's going to take quite some time for us to print, as you imagine. So I'd like our models just for this part to be quite small. So we're going to scale them to within a 6 centimeter cube. So slightly smaller than that, perhaps. Let's just check that actually. Yeah, he's 7 centimeters, just slightly smaller than that, just for examples. So just to manage expectations, we're not going to be able to print very big things. But we can print something if you wish. You can send us the file at the end of this session or over the next week or two, or next week I should say, and we will get them printed for you. So hopefully now we've all got Cura open. I'm actually going to find my file now, and you can do the same. You can find your file that you've saved from either last week or what you've done over the time since Owen's first session. So, of course, like everything else, I read CAD like a book. If I want to do something, if you want to read a book, you start on the top left of the page. And that's exactly what I'm going to do now. I'm going to go right to the top left where it says File, open up that menu, and below there you can see Open File. Just going to hit Open File there, look on my desktop, and there's my vessel. I'm going to left click on that and click Open. And there it is, nicely in the box. Hopefully you've got an object as well in there. I think what we should do really is think about scale now before we start to think about anything else, because I've just said it should be around about 6 centimeters to be able to get everybody's out. So if you hover over, and you can actually use the mouse to move in and out, I think you can press the mouse and lift, and that's the wheel, I should say. I'm hovering, I'm using the wheel to go in and out there. I'm pressing down and going up and down to pan, side to pan as well. And then, of course, I can left click and it highlights. When it does, you'll see these axes that you remember from Fusion. The one going straight up is the Z axis, going up and down. We've got an X axis and a Y axis. So the X-axis is red in this case, and the Y-axis is green according to this. So I can go to scale now down here, and scale is actually the second one down on the left. There's these icons on the left hand side, as you can see where my cursor is. So let's go down to the second one and it will give you the measurements of our object, which is 123, 123 and 100 high. So I was saying within, say, a 6 centimeter cube. So let's make it 60 high, and everything else will be a little bit bigger. I think we'll get away with that, perhaps. Let's make it, thinking about this, about 70 wide, shall we? So I'm going to go X. I'm going to change that 100 for 70. And it says down here, uniform scaling. I don't know if you can see that, but there's a little tick in uniform scaling. If you haven't got that, just click it so that it does actually scale in uniform. Otherwise, when we click on this and click OK, only one part will scale. I just have to enter. I'm just going to press enter on my keyboard now. And there you see it not only shrinks, but it's dropped down to the plane of the printer. Has anybody got theirs in the middle, just hovering? Quick question. Because there are settings within Cura, and you can just click a box that says drop to the bed of the printer.
All good, mate.
Fantastic. If as you go along you find that it's hovering there, there are kind of preferences within this. I really do like Cura. I mean, it's been going a long time now. For a free resource, it's absolutely fantastic. Okay, so we got our scale, and that's okay. The next thing we're going to do is just have a look on the printer itself. I'm going to just kind of zoom out. I'm going to go to the top one here, and that's basically just allowing me to move. And we've got this red one where we can move from side to side, and we've got the green one we can move side to side this way. And as we look at the bed, we generally put things in the middle. Try not to put things towards the corners, because you usually find, I'm not sure if Owen would agree with this, but I find that if we've got something that goes right into the corners, this is a heated bed, and sometimes it's not quite as good in the corners as it is in the center. So I'm just basically going to center everything like so. So the top one is move, the second one is scale. This one really doesn't kind of concern us that much, but it is rotate. I'm just going to move slightly. I'm going to go back to that. And the rotate, of course, if I go around this way, it's not going to do anything, but I can show you that it works by rotating this way. And as you can see, it rotates in 15-degree increments as we go around this way. And really for what we want today, that's fine. That's absolutely fine. Okay, I'm not going to leave the bottom ones now because we can actually duplicate things and we can mirror things as well in here. But I'm going to leave it at that in terms of moving our model around. The next thing I'd like you to see is, you can see there's red parts on our model. If I just move around, you can see. That's telling me that it's not really happy without actually giving this part a support, some support material. Now I know Cura and I know Ultimakers, and they will actually make this shape without them, because I think inside here is going to be an issue. If I put support material in, it'll have to be taken out. But there's another element we can look at in a minute to concern that. But it's a good idea, if it's telling you it needs support, it's a good idea that we do actually support it. So we'll add that in a minute. The other thing I'd like to point out as well is where it meets the plane, the actual base of the 3D printer, it's quite a small amount there, and it can actually move the model, which is a bit of a problem. So we can actually produce a raft, which is like almost like a plane that it prints first, that it then builds the model up, which is bigger and will stick to the base a bit better, or something called a brim, which is just a small amount of extra material. And I think for this, we'll need to put a brim on. So I'll just draw your attention to the drop-down menu on the right-hand side here. As you scroll up and down, we've got lots of different things to look at. The quality, the first one, is set at 0.15. That's absolutely fine to leave like that. But before we do, I'm just checking the nozzle size. which is at the top here. It says generic PLA 0.6 millimeters. If we open that up, we can get different nozzle sizes. And as you can see, the standard nozzle sizes for automakers are 0.25, which is tiny, 0.4, 0.6, and 0.8. We find that if we go to 0.25 or 0.4 even, a model will take much, much longer to print because the width of what's actually been placed on there to be printed is very, very small, so it takes longer. So 0.6 is kind of the optimum for us, and that's what I'd like you to keep to for these small pieces that we're going to make. So make sure our nozzle is set to 0.6. I'm just going to keep changes there. And there we have PLA 0.6, and that's my nozzle size. Quality, as I say, layer height 0.15. I tend to trust Cura. I have to say Owen is far more expert again in this field in terms of setting and optimizing these kind of things, but I tend to kind of go with what the software is kind of set up as standard. The next one is shell, which is the wall thickness and so on, line count, thicknesses and so on. Again, I'm going to leave that exactly as is. And then we have infill. This is quite an interesting one. With infill, if you imagine you've got a thickness, it might be quite wide, the thickness. We could make the infill 100%, which means that the wall is completely solid. Or we could put something in there with a kind of support structure. And in this case, our infill is a grid. But you can actually have different types of infill. As you can see, there are triangles, cubic, all sorts of different ones, crisscross and zigzags and all sorts. But grid, I think, is probably great. I've gone for a 20% infill density, which means that it won't actually fill in between the outside surface and the inside surface. It won't fill it all in solidly. It'll just put 20% in between. Again, that speeds your print up massively. Just makes it a lot quicker to be able to print. So I can change that percentage from anything from 20 to 100. I wouldn't go below 20, to be honest, but you could do, I suppose. Then we come to material. And again, these settings on here, I tend to leave as is. Close that. Speed, again, I'll leave the speed as recommended. Print speed according to this is 55 millimeters a second. I just worry that if I start to mess around with things that I'm not that familiar with, I could actually end up with a bad print. And now we come to, I'm going to leave travel and cooling the same. That's cooling rate. There's fans on the 3D printer, you see, so all of this can be changed. But the one that we really do need is generate support on here. So as we open up support, you can see these are the incredible amount of things you can turn on and off within Cura. There's an awful lot of functionality within here. And generate support, if you want it, you may have to tick it on here. But I think it probably comes in with that as a standard option. So I'm just going to close that. So just to make sure that in support here, we could just click on the tick there. And where it says generate support, you can turn that off. As you can see, there's no support, or you can click and tick it to generate that support. And underneath there, support placement is everywhere, and the overhead angle does change. It changes the amount of support that goes in it. I've left mine at 50, but again, Owen can tell you far more about that in terms of, I'm not quite sure what the right word is, but to make sure that that's optimized. I think that's the word I'm looking for. The very next one down here, I'm going to leave the support horizontal expansion because I don't actually know what that means because I've never used it. So what I'm trying to say here is there are some things that we need to pay a lot of attention to: nozzle size, supports, and build plate adhesion. I think are the most important things for us as beginners. Okay.
Can I just interject?
Yes, please.
Particularly for beginners, what is useful is that on the right-hand side of the screen, you've got above where it says print settings, there's a little cross there. If you cross that off, there is basically a drop-down menu with a lot of presets in there. So you've got like preset layer heights, infill, and so on and so forth. So that's a really good place to start, as you can see. So Ian
I just
put his mouse over
anything.
If you go to like normal, for
Yeah.
example, you should be able to click on that.
Yeah.
And you should be able to select a profile. So it's all under the profile settings.
Where it says normal here.
Yeah, and there's a little drop down arrow there.
Okay.
So you can create profiles, but these things can also be turned on and off there's an overall setting.
Yeah, yeah.
That's probably a discussion for another day.
Yes, okay, that's great. Thank you, Owen. Let's say Owen's far more expert than I am at this, because I do tend to just stick to the basics, let's say. So we've actually covered down to the infill. We've looked at support, and we've made sure we've ticked generate support. And the other thing I want to look at is build place addition. At the moment, there's none set for this. And I'm just going to tick, just click on the tick there to see what options we've got. Now, above none is raft. And what raft will tend to do is print quite a thick, about a millimetre or two thick area on the print bed before it starts building our model. It'll build the model directly on the raft. There's a skirt and there's a brim. Now, the one I use is brim. And when we do the brim, you can actually then decide how wide that brim should be. And it really depends with the model that we're producing, how wide the brim should be as well. But I've left mine at 6 millimeters. And I'll show you that brim in just a second. Okay. And then we have dual extension. Owen, could you just mention what dual extrusion is? Because I'm not quite sure.
Dual extrusion is for when you've got a printer that has more than one nozzle.
Cool. Yeah. Okay, we're going to stick to one nozzle for today, but we are going to show you a machine with two nozzles because the supports that we're going to create can be actually produced from a different material. And that material is PVA, which you'll probably know as a kind of wood glue, which is, of course, water soluble. So we have got the ability for particular models that are quite complex to wash them, put them in water, and the support material just basically dissolves. It just washes away over time. So that's great. Okay, so we're ready now, I think, to slice this object, ready for the 3D printer to print. Now, when it comes to it, I'm going to go down to the bottom corner here, and it says slice there. So I'm going to left click on the word slice. I think we actually will look at the, we've got so much time, I think we'll look at the software with the water soluble material as well. So now it's telling me that it's sliced it, and it's going to take 8 hours and 52 minutes to print that, which is quite a long time. So you can understand why we want to try and keep these things quite small. And that's 71 grams of material. And this is the material we'll be using. It's a filament, which is 2.85 millimeters. And it's going to use 71 grams or 8.99 meters, it says there. Okay. The next thing I want to do really is look at the support material and look at the structure of it as well. And if you look at the top where we've got prepare, the one in the middle there, it says preview. I'm just going to left click on that. It'll take a second to sort itself out. But what that gives me now is the actual model plus the support material that's automatically generated from the settings that we've kind of set on that drop-down menu on the right-hand side. If we have a quick look, we can zoom in slightly. Now, this support material will just break off. And what I tend to do is use a pair of tweezers or a pair of snips and snip away at it. But you can end up with little kind of nodules and little bits that would need to be cleaned up. So that's why we've also got a machine that has slightly different materials for support. As we look at this, you can also see the brim at the bottom here, which is the 6mm wide brim that we were talking about. And also we can see there are 465, we look right on the right hand side here, 465 layers in our model. I can prove that because it's a sliding scale. I'll just get everything in the screen there. You can grab the top there and left click, and then as you go down, we can see the support material inside. Sorry, I'm just going to move that around so we can see it. But we can also see the outside edge, the inside edge, and a 20% infill between it there. Now, as I scroll down, or as I use the slider there and we go all the way down, we can actually see the surface itself being created. And while we're doing that, we can look at our model and just check that we do have what's called a watertight model. So we go down now to the bottom, to our very first layer, which is the brim that we talked about. I don't know if you can see my cursor there. This is the brim on the outside here. Again, on the inside here, and the supporting structure on the base there. That's the first layer. So the idea of 3D printing is, if you imagine a glue gun and you heat this thing up, you know at the end is a hot end. You put your glue in there and you press the trigger, don't you? And it comes out, the glue. Let's say that we've got a very fine glue gun that comes out at 0.25 thickness. 0.25 is coming out. So if we just do a circle with our glue gun, and then the bed itself drops down 0.25 exactly, and it prints exactly the same thing. The bed goes down 0.25 exactly. It continues to do that for 6 hours. What it's going to produce, of course, is a cylinder, and that's all 3D printing is. However, you can't 3D print up and then go straight out, because it's got nothing to print on, hence the need for this support material to be placed in. So I'm just going to take that back up again. And there we have our finished model. Not exactly the most exciting thing, but there you go.
Can you show the X-ray view of that as well, please?
I can indeed, if I know where it is it?
It's under layer view, it's preview, and to the left there's layer view, view type, and it's a drop-down menu.
Where's layer view? Hang on a minute.
Just under the word Cura.
X-ray view. Got it. Never used it. What's the advantage of it, Owen?
With complex models, there might be faults or errors. There might be certain parts that you just cannot see particularly easily when you're using that kind of cross-sectional mode.
Mm-hmm.
Yeah, I tend not to use it so much myself either.
Yeah. Well, that's cool. I didn't realize it was there, to be honest. I tend to kind of go through my layer view because it's possible, if we don't get our models particularly right, we can end up with part of it being a solid and part of it just being a surface. It looks like a model, but it's only a surface. And as Owen explained last week, if we draw let's say a box, draw a square, that plane needs to be extruded before it's actually in the real world. It can be printed. If it's not extruded and it's just a plane, it doesn't actually have a physical thickness, so it can't be 3D printed. And it is possible. We get files quite often actually where it looks fantastic on the outside, but what we're looking at in some cases or some places are just surfaces that won't show up on the print itself. So it's a good idea just to kind of use that sliding thing to have a look. And I think the X-ray thing may well pick up on that as well, perhaps. Okay, that's great. So what we need to do is save to a file. And in actual fact, every 3D printer we've got here has got either an SD card or a memory stick. So all we've got to do is pop that into the machine and hit save to file. Now this is a Go, and I'm not going to save it onto that, but if you hit save to file there, you can see it's actually saving G-code. Now G-code is the reams and reams and reams of information required for a machine to follow the instruction. When we hit slice, it actually sliced it into 465 different layers and also wrote the code. So it would say X-axis will move 200 millimeters perhaps, and stop. The next line would say it would move such and such on the Y-axis or whatever. And that would then create all of the kind of, so you can imagine if you printed that out, it would be pages and pages and pages of documents. But that's essentially what we call the code. G-code is the information that goes from Cura to the machine itself. So we've had CAD CAM. CAD is our Fusion file. CAM is a machine. And Cura has actually taken our design and translated it into the code required to go to the machine. So in that sense, it doesn't really matter what printer you've got, because whatever printer you have will have its own software which will do this job, which will translate it for us. So I'm just going to pop that onto my desktop for now, but it would normally go straight onto an SD card. I'm going to pop that onto my desktop again and just call it Vessel and save. So that's now saved, and we can look at that. Now what we've just saved is the code, but we'd like you to do something else as well. I'd like to save the profile, the actual settings that we've got here, the whole thing, so that if we've just got the code and we send it to the machine and it doesn't work, there's nothing we can do about it. But if we go to File, in the top left here, and drop down to Save Project, there, and save, we can place that onto our desktop as well. And it's actually a 3MF according to this. And this basically will save the page that you see before you. It will save the work that you've done and the settings that you've got. And that allows us, if it doesn't work, to just go over and check those settings to make sure they're correct. And that gives us a fallback if there is a problem. So I'm going to do the same thing here. So I've saved it as G-code. Now I'm saving it as 3MF. Again, onto the desktop. And press save. Now it's saving. Okay, so hopefully now if I go to my desktop, you'll see I've got two files, one G-code and one 3MF. Let's just have a quick look, shall we? So there's my 3MF. To check, by the way, if you're not quite sure, if you just right click on it and go down to properties, and we'll have a look at that, and it says 3MF file, and there it is. So that's actually the page, the Cura page that we've got. So if I open Cura, I can open this in it. Also, we have our G-code file there. I don't have to right click on that because it's telling me it's G-code. So these are the two files, or the two formats of file that we'd like you to save if you want to have a piece 3D printed. Again, it would have to be quite small. If you haven't scaled it, we can scale it for you to make it manageable. So I'm just going to go back to Fusion, and perhaps I did want to show, I've got enough time to do this because we have kind of whizzed through this quite quickly. I'd just like to show you how you could draw on different points within Fusion. Owen and I were discussing this earlier to see whether it's kind of right for this level, but I think it probably is. Please do shout though if you need more time or if you'd like me to go over something again. I'm going to just hide my vessel now. I'm going to draw another sketch. I'm going to go to the bottom down here. And I'm just going to draw a shape. Let's see, if I go to create now, I can go to a polygon, make it a bit more interesting. Hit polygon there. I'm going to go to the center there, and as I go out, I can see there's 6 sides there. Doesn't really matter how many sides. 80 is absolutely fine, so I can hit tab and I can go to the sides, and I can make it 7, or I can make it 8. Oh, 78 is too much. I meant to do 8. Make that 8. I know you got 8-sided there as well. Okay, so I'll go with that, and I'll finish my sketch. I'll probably have to enter first, and there's my 8-sided sketch. So I'm going to finish my sketch now.
Hang on a second here.
Yep.
Let me see now. Abby says she couldn't find the nozzle size.
Okay.
That you were on about. So if
I'll
you'd
go
like
back
to go
there.
nip back to Cura.
No problem at all. Okay. Right. So back in Cura. Let's have a look now. I think because we're in preview, we can't see the nozzle side. So what I'm going to do is go back to prepare on the left-hand side there. And there's our nozzle size back again. It's underneath the word prepare is the generic PLA 0.6 millimeters. So I'm just going to click on that. And that opens this custom. And the nozzle there, 0.6 millimeters. I can then go onto the tick, and that drops down to the different nozzle sizes. So if you couldn't see it, it's possibly because we were in preview and not in prepare. So I'm just going to make sure that's 0.6. I'm going to keep my changes there, and I can go back there, and you can see 0.6 in the center there. Okay. Any other questions? But thanks for mentioning that, actually, because I hadn't realized you couldn't see it on preview.
Abby says that she doesn't have that nozzle size. And I think Gareth rightly is suggesting it depends on the printer you've selected. Some pizzas do not give options on nozzle size.
No, that's true. The actual Go, the small one, the Ultimaker to Go is only 0.4. And also, I think on the S3 and 4, we probably have to choose the nozzles on the left-hand drop-down menu, on the right-hand drop-down menu, because there's 2 of them. So that's true. Each machine will probably have a slightly different selection of nozzle sizes. So we're on Ultimaker 2 Extended Plus here. Let's just go back to it, and you can see the different ones I've got hooked up to it. I'll change to Ultimaker to Go, and it was probably too big for that machine. Let's see. Oh no, it'll still work. But on this one, it only gives me, or will only give me, a 0.4 nozzle size. And it won't even put it there as an option, because that's the only size that machine actually comes in. Let's go back to Ultimaker 2 Extended Plus, which is our standard, and hopefully you'll be able to see the nozzle size in there. If it's not there, you can just go to Add Printer and go to Non-Network Printer there, and you can choose the Ultimaker 2 Extended Plus, and there it is. I've already got it, so I don't need to add that. But you can click that and then press Add, and then you'd have that particular one.
There's something to note about Cura in that, generally speaking, if there's an error in the model or even the settings, it generally won't allow you to slice it. It'll come up with an error message. So
Exactly.
it
also, it's too big.
Well, it's too big, yeah, definitely.
Yeah. Is that okay?
Yeah, it seems to have solved that issue.
Cool, that's great. Okay, so we've got another 20 minutes. So what I'd like to do is go back to Fusion quickly. And I was just going to show this idea of, if I wanted to put another sketch on this plane, that's no problem. I could put sketches all over this plane. What happens if you want to put a sketch somewhere above it? I'd like just to point out, if we go along the top from Create to Modify, Assemble, the next one is Construct. I'm going to left click on Construct. And you can see Offset Plane is the first thing on that drop-down menu. Now, the idea of that is you can choose a plane and then drag it up and down to offset it at any height you wish. So this is how we kind of draw in mid-air in Fusion. It took me ages to get my head around this. So I'm going to actually left click on offset plane. And I'm going to put another plane. I can choose the plane that I've created or the plane at the bottom, which is exactly the same actually. So I'm going to choose the plane of my object there, and it gives me an arrow which I can bring up and down. And I'm going to make my plane 300 high, just so it's kind of looks proportionally right there. And then I'm going to click OK. So what I've done, if you remember when Owen brilliantly showed us the planes and the axis at the very beginning, the axis I should say, I can turn the origin back on and you can see, excuse me, the plane here, here and here. If we wanted to draw a sketch at the beginning, we could choose any one of these planes to draw a sketch on. But of course now we've also got this option as well. We could draw a sketch on there. So I'm going to do just that. I'm going to go to Sketch, Create Sketch. And I'm actually going to choose this plane at the top to create my sketch on. And that then brings that plane, and we can see through it to the plane below as well. And I'm going to draw a slightly different shape on here. Let's go to, I think I might just do a square to be honest. I'm going to create, let's go to, actually let's do a circle. Go to a circle there and center diameter circle. I'm going to go to the center and bring my circle up, let's say to about there. Doesn't really matter. And then finish my sketch. So I've got a circle above a polygon. So if you remember the easiest, I'm just going to move that, hide that origin. Of course, we can do that by going up to the origin on the left-hand side and just left click on the eye there. So we've got our extrude, or we can extrude an object up and down. We've got our revolve, which can revolve our plane around. And Owen also showed you the spline, if you remember. And it was a sweep, I think it was, where we take a shape and sweep along that line. And we could twist it on the way, make it smaller and larger. I'm going to see if I can remember how to do a loft between these two. So I'm going to loft between two planes that I've created to kind of fill the gap between the two. So I'm not quite sure it is, so I'm going to go up to Create. And I should point out as well that I never know where anything is in Fusion or any piece of software that I'm using. So I just learn to navigate. I know I'm creating something, so there's no point in looking at any of the other places. So I'm going to go to Create, left click on that, and I'll drop down until I find the one that I want, which is Loft, and there it is. And in this way, I think Owen mentioned as well, I always think of myself in the supermarket and going down the aisle and finding what I want. So there's Loft there. So I'm going to left click on it, and it's asking me profiles, which profiles to Loft. And of course, I've got two profiles here, so I can choose the top one first. And then I can choose the bottom one, and I'm just clicking on them, left clicking on them, and that automatically gives me a loft between the two, a new body. It's not particularly incredibly impressive, but there you have it. There's another object there that we've created. I'm just going to click OK there, and we've got a new body, and there you have it. So just another quick and easy way of producing forms. Just another recap as well. If you remember last week we looked at, I'm not sure if I think we looked at modifying, and we go down to fillet. I can actually put a rounded fillet on the base. I'm going to go to fillet there, and I'm just going to click 1, 2. I'll have to click them all separately really, won't I? 4, 5 and 6. And I can just type in 5. And there's a kind of really small little kind of fillet there, and you can see it's slightly rounded. If you take that back to 15, there's a huge one. I don't know if it will work or not, but there you go. There you go. It's a much bigger kind of fillet. It's kind of rounded there, as you can see. Now I'm going to cancel that. I just want to show you a slight variation on that. Because I've got quite an angled thing now, I can put an angled version of a fillet, which is called a chamfer on there. Again, through Modify, I'm going to go down to chamfer. It's below fillet, and as you can see, it's a more kind of angular version of the same thing. Again, I'll probably have to choose each separate line at the bottom here. I'm going to go for 15 again, 1, 5. And as you can see, it's a much more angled and regular variation. Now again, it's really worth noting that I haven't shelled this yet. I'm putting all of the kind of angles on there first, click OK to accept that, before I decide to shell it. Because if I shell this at 1 millimeter, and first, and then put this angle on, it would be a physical impossibility. So I put the chamfer on first, and then come and shell the top. So modify and shell, hit the top there, and I'm just going to put 1 in there, and click OK. And there's another vessel. I think I want something that needs more support than that, actually, thinking about it. So I'm just going to quickly make another object. I'm going to hide that. I'm going to go to Create, New Sketch, to the side there. And I'm going to produce something that will definitely need supports. So let's go to line in the top here. I can take that right out to there and click OK. Or it's actually the tip there. I'll put another line at the bottom here. So about there. Click OK. And I'm going to put like a curve that goes right the way out there. So we definitely need a support. So there's my fixed point spline, which I'll take straight up. Actually, I'm not quite happy with that. So I'm just going to escape out of that. And instead of the fixed point spline, I'm going to go for control point spline. And I just have a little bit more control over that. Take that right the way out to there. And if I want that's kind of a curve, kind of a undulating curve there, or rather kind of a lazy curve. I want a tight curve. I can just go quite tightly around there and put quite a few of them on there. And click OK at the end. And there's my form, which I'm going to rotate round. And I can move that around. Actually, I can't because it's still stuck in there. So I'm just going to escape out of that. So I'm back to my cursor, and now I can move that around to my heart's content to make a slightly different form. Okay, I'm going to finish my sketch and just make a quick kind of rotation around that. So create and rotate, or revolve, I should say. Sorry. Profile is this one. The axis is the edge there, and there's my body, which will definitely need a bit of support. I'm going to click OK, and then save it. So I'm going to go to body 4 here, right click, go to save as STL as we did before, make sure it's on high refinement and binary, click OK, and I'll pop that onto my desktop. It's body 4 at the moment, and I should have really given it a title, but I'm just going to leave it as body 4 and click save. Right, now this is demonstration only because I don't think we'll be using the S3 unless we need to on your models. What do you think, Owen? Yes.
Well, I think about what? Sorry, I was just typing.
Just about using the PLA material on some of the models if they're needed. I'm just going to go over that now.
Yes.
I was thinking we can save them as either the Ultimaker 2, or we could actually save them as the 3. I'll go through that now.
You could, or you could save them as the Go. Well, the thing is, they will work on each other.
Yeah.
Because of the form factors the same.
But I'm just going to go on to the dual nozzle.
I see. Yeah.
I'm going to delete this and change from Ultimaker 2 Extended Plus to the Ultimaker S3. Now, I think, to be honest, let's just stick to the Ultimaker 2, and this is just demonstration. Because I think that the S3 is going to be massively in use over the next couple of weeks from the students and so on.
I would give it a wide berth for the time being.
Okay.
Just mainly because usually with, say, like one of our printers, the S5, we can tell that printers are for that machine, for that machine in the file format that it has. Whereas the Ultimaker 3 has the same file format as, say, an Ultimaker 2, so it can be a bit confusing.
It is confusing, but I just wanted to demonstrate the difference in the supports. So this is demonstration only, but it's got 2 nozzles, 1 and 2. I'm just going to bring in my object, my file, And this one is called body 4. And open that up. And it's absolutely massive. So the first thing I'm going to do is change my scale as we did before. So I'm going to click on it, go down to scale. Looking at these, I'm going to make that 70. Making sure union scale is there, and you can see it's a lot smaller, but it's still quite big. Actually, because I put 70% instead of 70 millimeters. Haha, so let's put 70 millimeters in there. And click OK, and you can see it's absolutely tiny now in comparison. So let's move it. Go back to move. And I can move that, and it drops into the center of our printer. And I say this is just a demonstration of the capabilities that we've got in the Fab Lab. You can see a shadow there. I'm going to explain what that is in a minute. And also note that there are 2 nozzles here, a yellow one and a purple one. The yellow one is our model, the purple one is going to be the PVA. So I'm just going to slice that very quickly. So that's generated. And then I'm going to have a quick look at our preview. Notice there's only 0.4 in this, which is the choice we have on this particular machine. And this green, this purple part here, as we drop down now, you can see is the support material that supports the model. Let's just kind of drop that down a bit so we can see inside it. And you can see that I've set this at 20% support as well. So the actual support isn't solid. It's actually quite, it's not very dense. And you can see the infill is 20% there. We have a look at our support material as well. That should be in there somewhere actually. I think that's probably an automatic setting then in there. But you can see as we go all the way down to the bottom there, I'll just show you this part over here, which is like, it's a tower basically. And what it does is when it finishes one kind of part in the PVA, it goes over to the tower, it runs a little bit of material over there, and then it comes back and then it prints the actual model. And it comes back over to the tower, runs a little bit there, then comes back and prints cleanly on the next part of it. That builds itself up, as you can see, to support the whole model as it comes out. And when this model comes out, it just gets put in water. And in this case, the support just gets dissolved, it gets washed away. But I just wanted to show you that as well. However, let's go back from our to change back to our Ultimaker 2 Extended Plus, which is going to be the printer that we're probably going to be using for your prints. Okay, so we're about kind of the right point now to go on to talk about the actual 3D printer and how it works. So this is a 3D printer, and I'm going to turn it on. There's a little on switch at the back. And as you can see, a little LED should actually come out here. I haven't done this before because we generally have people in the Fab Lab when we're talking about how things work, and that's easy. It's not easy actually trying to figure out how on earth I explain how a 3D printer works. And then I remembered we've got this little thing which I can actually pick up and possibly going to bring a little bit closer, but I think that's probably as far as I'm going to go, to be honest. So I don't want to drop it. You can't see this, but there's a little LED and there's a box that says print on the top bit here. There's a little LED that says material and another at the bottom that says maintenance. It really doesn't matter at the moment, but what's important is in here, if I just take this out, is that SD card. I'll pop it back in again. Okay. And I just want to get this printer set up, ready to work. Unfortunately, when I came to it, this was the tube on the back, which delivers the PLA, which is the plastic filament. This is our plastic filament here. And this plastic filament has been in the box with this machine probably for many, many months and is probably quite brittle. But basically, that's the material, 2.85 millimeters across. There are two different standards of PLA filament size. One is 1.75, is it, Owen? And the other one, as you can see,
Yes.
it's so brittle, that just snapped off in my finger. I'm going to do the same thing here. It's not quite so bad, but it shouldn't be that brittle that it just snaps straight off like that. So it is too old to try to use, but it does give you an idea of the size of the material as we get it. That's around about, I think they come in either 750 grams actually when this is new. It's PLA filament. You can get slightly different ones. We generally find PLA is fairly cheap, and it's also good for the environment, or quite good, better for the environment than most plastics, I have to say. So, as you can see, the tube itself was absolutely bent, and the material is that was what I had to deal with. That was what was stuck in the machine. So I had no option really, but just to take the whole thing out and replace the tube. So here's our replacement tube. What I need to do is turn this around and fit this tube into the machine before I can actually continue to work with it. So it's quite a nice thing actually for you to see the machine not working. We'll see if we can get this running. So I'm going to turn it around so we can see the back. Okay, the first thing I'm going to point out is this bit here. There's a motor here. And remember when we pressed slice on Cura, it not only took our model and sliced it completely, but it wrote G-code. And that code was given instruction to each of the motors on this machine. And one of those motors is the motor that brings the filament up and over and into the hot end so they could start printing, just like a glue gun, as I mentioned. So what I need to do is fit this tube now onto the top of the motor. And there it is. And there's also these little clips, tiny little clips, which are very, very easy to use. And what they do is you pop that underneath that little fitting there. And that holds so it can't pull out, basically. It's actually in place there. So I'm going to move this around again. And we've actually got inside here a hot end. I'm not going to drag it around at the moment because it's on, but it's got another one of those holes at the top of the, hoping that's going to be all right. Let's pop it in. Okay, let's go fairly far down. I'm going to put the other clip in. Okay, so that clip's in place. The black material here, or the black ribbon here, is actually the wiring. So I'm going to clip that to the new tube. Right, so there we have it. So now hopefully we've got everything in place to be able to load our material up. And this material is just a small amount of white. It's come off a machine just recently, but I've just noticed a slight problem with it. At this point, I don't know if you can make it out, but here, between my fingers, there's a bit of damage. Can you see that? So I need to cut that out because that is going to be a problem when it goes through the machine. So I'm going to cut it straight to start with. And then, because I know this machine, it doesn't like a straight bit of material going down. It sometimes comes along and then stops and won't go any further. And that could quite be the case this time. We may not actually get this running, but it's quite a good thing to see if we can. I'm going to snip this into a point. It's not the best pair of snips. So hopefully you'll be able to see there's a bit of a point on the end there. So I'm going to put that on the back of the machine. I'll come around to the front now. I'm going to turn this dial. It's now going from, you can see it's just highlighted. It says print there. It says material there, or maintenance there. I'm going to go to material. I'm going to go to, and it only gives me change. So I'm going to hit change anyway. Change material. So it's almost as if it thinks the material is already in it. It's not a problem. It will just retreat back and then allow me to load material back onto it. So while that's happening, it's going to take a bit of time. I'm going to show you one or two models. So I already showed you the print of the little face there, and that was 3D scanned, as you can see. And you can't really see, but there are lines. If I hold that to the camera, move around, I'm hoping you can see the lines there that make up the model. In another session, Owen's going to show you slightly different machine that actually doesn't have lines on there. It's a more industry standard thing, but this again is the same kind of thing here that's been 3D printed. And again, you'll probably make out the lines. I'm just going to put my finger there. There's a couple of lines there you can possibly see. So this again has been 3D printed from one layer to the next, to the next, to the next, and so on. The end here is getting quite hot now. You can see it's actually heating up. This machine is very basic, so it doesn't have a heated base. So sometimes we have to put a little bit of like a Pritt stick almost on the, this is actually masking tape here. It's kind of a good quality masking tape, and it sticks to that quite well. I'm really hoping that this is going to work. If it doesn't though, it's not a major problem because it still shows you the functionality. So as well as the motor that we have at the back, we also have a motor in the corner here, which actually drives I'm just looking at this, and it's the y-axis which goes forwards and backwards. There's another motor down here which drives the x-axis, which goes side to side. It's just heard it retract, so it's telling me to remove material, which you've already done. So I'm just going to press ready, and now it's asking what material it is. So I can scroll up and down here and choose what type of material, and I can see PLA as one option, and then we have CPE and customs. I'm just going to leave it at PLA, which is our standard, and hit that again, and now it tells me insert new material from the back of your machine. So I'm going to do just that. Turn it round. And what's happening is that this motor is turning around very, very slowly. And you can't really see it, so I'm going to take this off for a second. So this motor, I can hear it's revolving really quite slowly. So I'm just going to insert this into the bottom of the motor, and I can hear it and feel it. It's just taking it from me. And there you have it. In a second, you possibly see it coming out through the top. Hard to see, I know, from where we are, but that's now being fed very, very slowly, and I can just see it coming out the top now, coming out through the top of that motor. So I'll fit that back on. It's not a great fit, but it's just for demonstration purposes. I'm going to turn this round. So it's coming slowly through that tube, and it's telling me to hit ready when it's taken. So I'm going to hit ready now. And now it's actually turning quite fast, and I can see it coming right over the top now, and now it's coming down towards the hot end. And I'm really hoping this will come all the way through and start to come out our print head here. Now I think it might be worth me just bringing this forward and I can already hear there's a problem. It really doesn't like. So I'm cheating, and I'm actually got my finger on the back, and I'm pushing up as well as the motor, just giving it a little bit, and I can feel now it's going through. So I could feel it having a problem. You can see the 3D print coming out there. I'm hoping you can anyway. Hopefully you can see.
Can see a dangly thing.
Can you see a dangly thing coming out? That's basically the filament has come through the top and is now coming through the base here. What I don't like is the fact that this bed seems to be quite high, a lot higher than it normally is. So I'm a little bit nervous about what it's going to do when I set it to print. But basically, I'm happy with that. So I'm going to click ready. I'm going to press the this button here to say ready, and it will stop. And there's the print that's come out of it. Okay, so I think we should set this to print. Not very happy again, as I say, about the height of this, so it might go horrendously wrong. So I'm going to go back now and produce something from our file, perhaps. I'm going to go to return and go to print. And I'm wondering whether we've got a little print on here that we can just demonstrate and see if it works. As I go through, there's probably a whole number of different size EVA mask, and I'm looking for something quite small that we could just set it to print. Okay, geometric heart. So I'm going to go for that anyway. I'm going to press go. Oh, by the way, if we want to actually print something from Fusion, of course, we've saved our STL, haven't we? We've put it through Cura, and we've got our G-code. All we've got to do is put the SD card in my machine and just hit save, and it's on that SD card. Press the SD card into the machine, and then it will be on this drop-down menu. So it's as simple as sending a Word document to a printer. It's just a simple process, really. So our model is already on there. In this case, it says geometric heart. So I'm going to press this, and hopefully you won't hear this noise, because this bed, as I say, I'm not happy with where it is. It might come straight up and make a weird noise, in which case I'm going to shut it all down and get it to reset. So I'm going to press go. Oh, that's good. It went down first, didn't it? So there are limit switches on this machine. Do you know when you put your printer on at home and you turn it on and it whirs around like a mad thing for ages? Well, basically, what it's doing is it needs to find out where to start before it can start printing. So the bed went down, didn't it? So what it's gone down till it's hit a limit switch, so it knows that's where it should be to start. The print head is used an X and a Y axis, and it's gone into the bottom left corner if you think of it as a page. Most origins are usually in the bottom left. So it's now sitting, if we're looking down on it, in the bottom left corner. It's hit a couple of limit switches there as well, so it knows where to start, basically. What it's going to do now is it's heating up. The bed will rise up to meet where the print head is, okay? And then it will start to print its first layer. Once it's done the first layer, the bed will go down 0.25 millimeters, and it will print the second layer. The bed goes down, and a third, and a fourth, and so on. That's basically how it works. It should start any minute, really, but obviously we can experiment and we can 3D print with lots of different materials. We've mentioned we have a resin printer that Owen will describe, I think, in session 4, I think it is. We've got a nylon printer, which I haven't used, but I've used a lot of powder printers in the past, which is basically similar kind of technology. Here we go, it's just starting. And what it should do is just kind of start printing a kind of bit in the corner there, and there it is. Once it's done that, it should come and start to print. Now, this hasn't been set up for years, probably, so I'll be very surprised if it prints at the right height, because the layer has to be set, and wouldn't you believe it, it's working perfectly. And I have to say, in 1 year, I did 70 school visits with this machine and set it up once, I think, and it was absolutely amazing. And that's the reason why we use Automakers. There are lots of other makes out there, but it's a bit like Motor Guzzies for motorbikes. If you love the look of them and you like fixing bikes, Motor Guzzi is brilliant. Whereas if you want something reliable, you might want to go for something else. This is reliability and really good finish as well, I think. So that's printing really nicely. And that takes us to our break time. So I'm actually going to let this print in the background. I don't know how long. It's 50 minutes, really. So it's 7 o'clock now. So it should be completed before we finish this session, I'm hoping. So this next part of the session is to do with, and I'm just going to move that back a little bit because it's quite noisy. It's to do with another bit of software called Slicer. Now, in order to use Slicer, we can do a number of things. We can produce something ourselves in Fusion, or we can grab an object that's already in existence. And in this case, I chose a shark. And there's my shark. It was a solid object, which has been kind of sliced up. And the intersections, it's really interesting. I can't get this off. It's such a tight fit, I can't take this out. We also have a cardboard box here, and I can take one of those intersections out easily, and you can see that it also engraves numbers. So it's a 3D jigsaw, which I think is absolutely wonderful. And this is what I want to show you next. It's a little bit of free software, which allows us to take solid forms and create these quite complex files from them. There's also a scan that Owen's taken. Hope you don't mind me showing this on. This has been made in plywood. It's 4mm plywood that it's been made on. But you can see there's a profile of a face there that's been created as well. So if you wouldn't mind, if you could open up Slicer, I'm going to do the same. It was a Fusion element. It was actually part of Fusion 360, but I don't think it's supported anymore. So even though mine says Slicer for Fusion 360, I just have it as a standalone. Downloaded it separately and open it separately. So I'm just going to open up. Actually, there we go. I think what I'll do is I'll show my screen first.
I was just going to add that with Slicer, that it's a really valuable piece of software in that you can take three-dimensional objects that are created virtually, which, by the way, it's very difficult to really get a sense of scale, the virtual world, and you could rapid prototype them using slicing and laser cutting to create three-dimensional models. You get a much better idea of how that form will occupy a space, as opposed to just maybe 3D printing straight away, which takes hours. You can use up lots of material.
Absolutely, absolutely. Also, the idea of using wood. Sorry, Owen, you carry on.
That was it, man.
Yeah, Owen obviously does a lot of work with large-scale furniture and that kind of thing, and using the CNC router and wood, which costs a fortune. 18mm thick piece of plywood, for instance, that's 2.4 by 1.2 size. It's close on £100 with VAT and everything, isn't it now? And it's really quite expensive, about 80 odd quid, let's say, to 100.
And increasingly hard to come by.
Exactly, yeah. Whereas cardboard, you can make the most amazing large-scale things with cardboard, and then maybe cover them and that kind of thing. It's a really fantastic and cheap, quick way of producing large objects. The laser cutters can travel very fast with certain materials, whereas the 3D printer, we're restricted within that box. And even our largest 3D printers are only about 300mm high, and I'd say about 200, 250 kind of box shape. So it's only really that kind of scale that we can 3D print. And yet with Slicer, we're kind of free to make each object or each slice the size of our laser cutter, which is 1.2 meters across. So if that could be 1.2 meters wide, we can make that just as easily using cardboard and actually have a huge scale very, very quickly. In fact, I could have it finished by the time this is finished, which is really quite amazing when you think about it. So a very, very useful bit of software. I'm going to start off by, I think, making something in Fusion. And then, because I'd rather not kind of go straight to Thingiverse and start grabbing things, but we will go to Thingiverse in a minute just to show you how easy it is to grab a model and then use that in Slicer. But I think let's keep to Fusion. That's essentially what we're here for, is to learn how to design and so on. So I want to design something like this. It's going to be a solid shape at an angle, and it's going to have a bit of a thickness to it. Shouldn't take long to make if we extrude it. So I'm going to go, am I sharing? I'm not sharing yet, am I? So if I present my screen and share, hide that and go to Fusion. Hopefully you'll see a blank Fusion page. And I'm just quickly going to knock up something that we're going to take into Slicer. So I'm going to go for about 150 millimeters square. So I'm going to go to Create, go to Rectangle, from the center, take that out, and I'm just going to type in 150 and tab and 150 tab. Right, and then enter, and I've got 150 square. I'm going to finish my sketch, and we know from that first session that Owen did that we can extrude that, and we can add a tapered angle to it as well at the same time. That's what I love about Fusion. There's multi-functionality within everything, and I haven't got a mouse, so I'm not quite sure what I've done. Here it is. It's a bad work when you can't find these tools. Right, okay, I'm going to take that down slightly. Let's extrude that. Go to our extruder, take that up, and I'm just visually looking at that, thinking, yeah, around about 100 high, should be okay. Yeah, should be okay. So I want to put a taper on that. So I'm looking down here at the angle, and there's the angle there. I'm going to change that to 5 and just see what happens. It's going out 5 degrees, maybe a little bit more than that. Let's make it 10 degrees out. That's not too bad. I think I'll go a little bit higher, you know. I'm going to take that to 120 high. I'm going to take my taper to 50. As you see, we've got lots of functionality within this. I'm going to click OK. And there you have it. You don't have to follow this, by the way, because I'd like you to make your own thing to put through Slicer. It's just a very quick demonstration of Slicer and how it works. You can take anything in that you wish. I'm going to draw another, I'm going to shell this actually, but I'll shell it really thick kind of walls, because I want to have something like this with a kind of thickness to it. So I'm going to go to shell in modify. I'll choose that top plane there, and visually I'll just type in something like 20 and just look at that, and that's not quite enough, so maybe I'll do 30. That's not bad. Let's see what 40 looks like. If I have that as a net, I could actually put something in that, maybe put a plant pot in that or something, I don't know, but I'm just going to leave it at that for now and click OK. And it's just a very, very basic shape that we've constructed. Let's put a little bit of a kind of angle at the bottom here and put a little bit more interesting chamfer on it. 2, 3, and 4. I'll make that 10. Chamfer on there, okay. Great. So I'll take my model out now, save it. I'll go to bodies there, and body 1 is inside the body folder, and I'll just call that square. There. And now I'll right click on square and save that as an STL. That's our solid model that we could send to a 3D printer. And we'll just click OK there. And again, just for ease, I'm going to pop it onto the desktop. It's called square and it's an STL file, and save. So now I've got a saved model on my desktop. I'm going to open Slicer. So here we have Slicer. it's just an empty page, and I've got to apologize straight away. Hopefully you've all got this as well, but on the top here, it's really small, this little tab that says import. Notice as well when you go to the top, you've got this drop-down menu, open, save, and so on. But there's also import. So I'm going to go to import and left click on that and then search on the desktop for that square. And there it is, square STL. You don't have to do this with the model. You can just watch this bit and we'll come back because you are going to be doing more of this yourself. I'm going to click OK and open. And there is my model. Notice, by the way, that when we look at our top, even though it's come from Fusion, it's actually not in the same, I'm going to say, in the X, Y, and Z axis, as you would imagine. It doesn't really matter that much because I can kind of move this around. So I can just hit bottom there, and it's kind of looking at the bottom, but you can move this kind of square just like we do normally anyway. We can probably revolve that, but I'm not going to worry too much. The most important thing we need to do, though, I'm going to set this up in wood, in plywood. And the most important thing to do is to understand our material before we actually start to split anything, before we need to do anything at all. And what we've got here is a piece of 4mm thick plywood. It's laser ply, which means it's safe to cut on a laser. I think it's to do with the glue in there, really, the type of glue between each kind of each layer of wood.
Non-phenolic.
Sorry?
Non-phenolic.
There you go. Thank you.
Right.
Thank you. It's 500mm across and 375 down this way, and 4mm thick. So what we've got to do really, if we look at our drop-down menu, underneath our square there, we've got this edit and letter 85 times 11 times, and that's basically the size of a small kind of letter, I would imagine. And it's also in inches, we can see. So we're going to change all of this, but what we have to do is we have to make sure that in our list of A3, A2, A1 letters, B5, these are all sizes of sheets of material. We need to add one, and I've already got mine here. It's a plywood, but you're going to need to add something. So I'm actually going to do this with you. What we're going to do is next to it, when it says letter, there's a little pen, which is edit. I'm going to left click on it, and it's going to open up a drop-down menu with all of those kind of different materials on it. And it's in inches, as you can see. What we need to do is add a new material before we start. Now we can choose to add a 6mm thick cardboard or a 4mm plywood, but we probably need both of them really if you're going to use both of them. What we're going to do is we're just going to set up a job for plywood. Now, this has been recorded as well, don't forget, so you can always go back and set another one for a 6mm sheet of cardboard. And just for, we've got big sheets of cardboard, but I'm going to say your cardboard should be 6mm thick, and let's say 500 by 500 is quite a nice kind of scale that we could set up. What I'm going to set up for plywood, I've already got one on my list, but I'm going to do a new one. So I'm going to go down to the bottom of this square, bottom left, and there's a plus there, and it says add materials. So I'm going to left click on it, and what I've got now is unnamed 0, and a whole load of live boxes on the right hand side that we can start to fill in. When it says unnamed, I'm going to click on it twice, and now I can type in something, and I'm going to type in ply, L-Y. Only for my use this, so I know it's plywood. Then I'm going to type in 4mm times 500 times 375. I'm not sure if it's 373 or 375, but I think 375 should be fine. So it's plywood.
375, mate.
375. Thank you, Owen. So that's done. Before I do anything else, I'm just looking at the units on the right-hand side now. What we're going to do now is we're going to set these units to be the same as our material. So I'm not going to work in inches. I'm going to swap that for millimeters. That's the first thing I want to do. The length and the width here have already been specified, but we're going to change them. So I'm going to highlight everything in that box where it says length, and I'm typing in 500, 500. Once that's done, I can go to the next one, and you can see the 500 is now entered as soon as I go to the next one. And I'm going to put in our width as 375. Let's go down now, and the thickness, it says 4.5. I'm going to take that back to 4. It's a 4 millimeter thickness. And the reason I've done that is because if I just click enter, I think that 4 is set. That's great. Have a look down the bottom here. I'm going to leave the horizontal margin and the vertical margin exactly as it says, 5 there. Mainly because I don't know what it is. And I would imagine it's a margin around that area that we could work within. But if we go down to cutting tool parameters, which is right down the bottom here, the tool diameter is 0. I suppose we could set that to 0.25, but our slot offset here has already been set. Now, the slot offset is vital when we think about how things are going to interlock. If we've got a 4 millimeter hole and a 4 millimeter piece of wood that's going to go in that hole, there is no way you're going to get that to go in. Even with a hammer, you'll never get it to go in, because you need a tolerance actually to accept that 4 millimeter. And generally, I tend to say 0.25. It's what's automatically put in here as well. And Owen will probably tut under his breath here, because I always do that on router jobs on the big CNC router. But he'll probably have a much more scientific method of working out what that offset is. But I generally work 0.25 as my standard kind of, let's say, offset that's needed to allow something to go into a hole. So even though we've put a thickness of 4, we've actually got a slot offset of 0.25, which should be adequate. Owen, were you going to say something there, please?
Yeah, I was going to say, in terms of larger scale objects, if you're, say, machining 18 mil plywood, for example, offset's really, really important. In terms of laser cutting, with 4 mil ply, it's not so important as such, because at the end of the day, you have to bear in mind that the beam of the laser has a diameter, so there you have an offset there. But with more complicated pieces, like as Ian showed that the profile of the face, that was a lot of interlocking pieces. It was really difficult to slot together because it had no offset. So I'd agree with Ian, you need some offset just to be safe. And it can always be adjusted at a later date if it's not to your satisfaction.
Yeah, I mean, this one, for instance, I wanted to do very quickly before we started today. Anybody who was on the slicer introduction, the very quick introduction I did, would probably see me kind of working on this sharp thing. I had to hit it really quite hard to get these things to go in together. So in actual fact, I think we're going to leave the offset at 0.2, but I think we'll put a tool diameter in this as well, because that was too hard to put together. So let's put 0.2 on the thickness of our laser. It's probably 0.25, but I think
it's 0.1.
Sorry?
The laser beam on the 120 watt is 0.1.
Excellent. So I'm going to put 0.1 in that, which is going to just give us that little bit of extra freedom to be able to slide these together without it being so, you know, having to hit it with a hammer. However, after said that, it is really quite a solid thing, but I think we need the standard offset that's recommended at 0.25 and a tool diameter of 0.1. Once we've done that, we're just going to double check that it's correct. So I'm going to go right to the top again, millimeters, 500 by 375 is our length and width. Our thickness is 4. The margins I've left at 5.08. The cutting tool parameters, which is really important, the slot offset is 0.254, and a tool diameter, which is the width of our laser beam, is 0.1. And then we can click done at the bottom here. Once we've done that, that material that we've just set up is one of the options, and probably the bottom option, as we have the drop down menu here of different things. Right down the bottom here is my ply 400 by 500 by 375. So I'm actually going to click on that now, and you can see it's now the selected material that we're using for this particular piece. Now, if we look at the object size now, it's 8 by 4 by 8, but it's actually still in inches. So I'm going to change the inches to millimeters. And now we can see it's 200 by 100 by 200. So it's about 200 square, which is about the size of that. So I think that's probably pretty good going. I'm not actually going to make this. I'm just going to go through the process, okay, so you can see it. So I've got my size right. If you wanted to change the size, it's exactly like Cura. We can make sure we've got uniform scale clicked here. I've just clicked it off. I'll put it back on again, and you can see uniform scale. I can change any of these sizes, and it really is quite important because we need to kind of think about our material. What we don't want is a design that uses all of this and a tiny bit extra. You've gone onto another sheet. So in actual fact, it's called nesting when we actually try and figure out what's the best way of actually putting all these shapes onto our material without too much waste. So we can change the scale of this quite dramatically, quite easily. And our height is 203. I'm going to change that to 180, 180. And at the same time, I've got uniform scale clicked, so I can just enter. And the whole thing just goes smaller to whatever I've decided that should be. That's great. So now we have our object and we have our scale. That's fantastic. Brilliant thing about this is, as it says construction technique, select a technique. I'm just going to have that drop down menu here. And we've got lots of different ways of making this. So the first one is stacked slices. Now it'll probably stack that way because I've turned it around. So let's click on stacked slices. Oh no, that's perfect. As we go around, and you can see the way that this is created, it is going up and down to the side, and it's stacking lots and lots of slices from top to bottom. All of these are 4 millimeters, and it's given us 1, 2, 3, 4, 5, 6 sheets of this material to be able to make that object with stacked slices. That's all well and good. If I want to change now to an interlocking construction technique, I'm going to go to interlocking slices, and now we have 3 sheets, and we can move this around and we can see the complex form that we've got in our example. Okay. And it's given us 3, but can you see how badly it's actually put these together? I can probably fit on the right hand side here quite a few of these at the top. Quite a few at the top going this way and quite a few going that way as well. So it is possible to take these designs and then remap them so that we're using less material. We're still going to use more than 2 sheets though. One way around that is to reduce the amount of slices we've got in there that's needed. So at the moment, if you look down, you can see there are 10 axes in the first axis and 10 in the second axis. I'm going to swap them to 8. So I've just highlighted 10, and I'm going to make that 8, highlight 10 there, and make that 8. And you can see there's a lot less now in there. And now we're back to 2 sheets. So we've got 2 sheets that we're using, and that to me is a lot better in terms of material. Because if I'm making some of these, make some more of them, obviously some of these can go on the top there, and we can probably make more as we kind of develop this, if you know what I mean. So that's great. We can now have a look at, let's just take that right down to 4 on each, by the way, just to prove we can. Completely different designs, just at the drop of just typing in, basically. You can put whatever you want in there. There's a slice direction in this as well. If I just go to the slice direction at the bottom, underneath these settings, hit that, I can change the direction that I'm slicing at. So there's one here that's going around top to bottom, and one here that's going around. So I'll take that and I'll change my slice. I'm just dragging. And can you see what happens as you drag around? The design changes completely. I've not got enough really. I'm going to take that back and put it back to 10. Or maybe 8. That was quite good, wasn't it? Go for 8 on both. And I'll change that slice direction again. Now, you can see as a design tool, there's some fascinating things we can do here, just with the simplest little kind of form that we've just knocked out of Fusion. I quite like that, and we're still on 2 sheets. So I think what I might do actually is save this and produce this as a model, maybe for demonstration for later and for next session. So once you're happy with it, there's other techniques as well. I'm actually going to just show you some other kind of variations. There's a curve, and that's basically just a slightly different method of slicing. You'll probably see that better if I hadn't have kind of twisted the direction. And there's also radial slices, which means it's coming from one center going out from it. So you can see there's all sorts of different variations we can play with. Let's go back down now to folded panels. Now this I'm not quite sure about, haven't used it, but what it does is it gives you a template that you could laser cut that will fold to make the object that we see in front of us. And yet it does seem to be a bit of a glitch here. And yet, no, I think that would probably work. So it's given us 2 separate pieces of paper, basically, that will fold around. Never used it, don't know how accurate it is, but fun to play with, I'm sure. Okay, so we've got that, and then we're back to 3D slices, which is basically sliced. And because I've moved that direction, it looks a little bit more interesting. It's exactly the same as the slices we had at the beginning, actually, as those. Let's go back now to the stacked slices there. It's just actually because I've changed that angle. I really like the interlocking slices at those settings, and I'm really happy with that. So, just to recap, we've set up our material. So we know what material we're using, the size of it. We know what thicknesses it is as well. We've taken our model in, and we've tried a number of different ways of slicing it, knowing that we can actually move things around as well. Now, you can actually with these, edit these yourself. I don't want to edit it myself, but I'm just going to show you that it's possible. If we go down from slice direction to modify form, I'm just going to left click on this. I'm just getting a bit nervous that I've talked for a while. I'm just checking that you guys are still with me. Owen, are you with us?
Yes.
Excellent. My fear is clicking the wrong thing and going offline and carrying on for an hour and you guys can't see. So I'm
still listening.
Form at the moment. I can click any one of these panels and move it. And you can see instantly it's allowing me to, let's just move that so we can see what's happening. It's allowing me to move this object at any point along and instantly working out the tolerances and everything around it. I'm going to take it back to where it was, roughly, because I quite like that. But it does mean that if you've got certain problems, and I had the problem with this shark, this fin carried on to here, but the cut to make went all the way down to the point where it almost, well, it did actually cut all the way through it. So part of the fin just came off completely. However, I moved some of these up and down so that this part here was actually in the fin, in the middle of the fin, because it was over here. So I just kind of moved them all. What I didn't think was to move that. So you can actually slide all of these things. And the thing in the middle here was too wide. So I pushed everything back in and made it a little bit tighter as well than the original kind of model. So we've got total freedom to move everything around. Right, so once we're happy with our design, okay, I'm going to go down to the next one, from modify form, the next one down, just working our way down, is assembly steps. Now you can see at the moment it's set as cardboard. I'm working in plywood, and if we just go down to cardboard at the bottom left there, we can set it to ply, and it's just a render, just a cheap render really that shows you it in kind of plywood there. Makes no difference what we're using, to be quite honest. It just gives you an indication. What I love about this, and I like actually to film it, I set like OBS Studio or something in the background and film myself doing this, because at the moment it's showing one of our shards on the top left, or top right I should say, is highlighted. And we've also got like an animation here, start to end. I'm going to drag that all the way down. This time I can just hear the 3D printer is just finished. So we're going to pull that thing off and have a look at it in a minute. But what it's doing is it's showing me at the start of my animation, if we can move that around, one sheet that we've got in our design. And it's also showing which that one is, which is sheet 2 in the center top there. And we've got numbers here as well as the outline cut. We've got Z2. So in one axis Z, we've got 2, 3, 4, 5, and 6, and so on. In another one, we've probably got a different axis as we're looking, because there's lots of Zs there. As we're looking down here, we've got Ys as well. So these are across the Y axis and the Z axis. But it's showing me which one that one is. If I start to move my timeline across, watch them appear, slot together, and tell me which one of them it's going to be at the same time. I'm just going to move that around slightly so we can see it. And then I'm going to slide slightly, and we'll see another piece, which is the bottom one, and how that goes in. Then the next one, and the next one, and the next one, and so on. Now, this is important, because this is a simple shape. But if it's not a simple shape, the way that these go together is really vital, because you might have to pull it all apart again, because at one point you'll realize, as I did with this, that it has to be fed through the mouth and then around to be pushed back in, because this is all one around here. So you get really complicated parts. So it has to be put together in the right order. And Slicer is telling you what order that is. So as you go through, you can take it apart again. You can move that around so we can see it from the top. And then we can do that again, just so we're absolutely sure how they're going. Now, really, you don't necessarily need this, because you've got all of the numbers and so on our design as well. But I like to actually record this as well if it's a complicated model. I don't want to spend too much time figuring out what goes where. So that's it. We've got our assembly steps. We know it's possible and we're quite happy with it. We need to save it now. So I'm going to go right down to the bottom of Get Plans and hit that. Now, there are lots of different ways we can save. We can save as DXF, which we normally say is our standard way of saving. But we've also got EPS and we've got PDF. And I would very much like us to save in PDF. The reason why is if we save as DXF, there's a kind of glitch that takes place, and the line that's produced is haphazard. It's made up of many, many lines, and even if you join them all together, it's a kind of scratchy, very long-winded way of making. If you save it as a PDF, we can convert that into a DXF, into a clean DXF, and it's much easier for us to work that way. So if you want to use Slicer, just save as a PDF, and the way to do that is right down the bottom. You've got EPS as the first thing there, and I'm going to select the second one down, PDF, there. Once I've done PDF, I can export to my computer. Don't worry, by the way, it says inches there, but it does come in the right scale for us, and we can actually work with it. We can export to my computer. Okay, it's a PDF, it's on the desktop, and I'm going to call this, say, design example 1 slicer. That's going to go onto my desktop and save. So I've now got a PDF from Slicer on my desktop. Let's just check it's there. And it should be in a, I'm just seeing if it is actually. I don't see it. I'm going to do that again. I'm going to go back to Slicer. I'm going to go export to my computer, make sure I haven't made a mistake. There's my desktop. Okay, we'll call it square this time. And PDF file. Square PDF file. And design example 1 Slicer is there. So I must have just missed it. So let's just save that. Apologies for that. And double check. And I always double check before I close this down. Okay, and there we have. We've got design example at the top there, and we've got square PDF file there as well. So we've got it. That's fine. So that then can be taken into our software. It'll take me a few minutes probably to get that to the right format to go to the laser cutter, but we're actually going to show you that next week when we do sketches. I think what we'll do, we'll put that through. But in the meantime, I'm actually going to go online and show you how to download a model, any kind of model that we can put through Slicer. But it's called Thingiverse. If I'm just put thing there, you can see it comes up on my search as Thingiverse with an I, V-E-R-S-E. I think I probably put the link in last week as well. If you go on Thingiverse, I can probably find that shark that I used, and it doesn't actually work. It comes into Slicer and it doesn't work. So what I had to do is make it into a solid because it was faulty. It was a set of surfaces rather than a solid. So don't be surprised if sometimes when you bring a model in that it won't actually work. We would have to actually fix that, and I will show you that in session 5. So it may be that you can try a model. If it doesn't open in Slicer, just try another model so that we can get something in. I'm going to go for an elephant. So I'm going to search Thingiverse and just put elephant. It could be anything, really can. And then it will show me the elephants that we've got. Okay, I'm going to scroll down and look for a particular one. Okay, well, not in the first one. I'm going to go into the second page there. And carry on down. And there's an upside down elephant, which I love. I'm going to take that. So I just clicked on it, and it opens up this, and it says download all files. And it really is as simple as that. This is free to use. There's no cost. But what you've got to realize is these are people's files that they put on. So there's intellectual property that has to be recognized. So you can't really just print these and sell them. It's not allowed. We can actually mess about with them a lot, but it's a really good idea to credit or it's a bit like using someone's photograph, isn't it, really? But this is by Yahoo Japan, is that? Yahoo Japan. So I'm going to download this now. Download all files. Yep, and it's downloading files, and that should appear at the bottom here. And all I do, to be quite honest, is drag that onto my desktop. I am quite fussy over how I do these things, so I'm just going to take that down slightly and just drag elephant onto the desktop. And I will have a cleanup at the end of this session. Now, this is a zip file. Okay, so in that zip file, we're not going to be able to find that if we go onto Slicer and go to import. It won't see it. So we have to take the file out of the zip file. So I'm going to open the zip file. And you can see there's a thing about the license there, test document, something to read. Sometimes a lot of these files have got lots of information that's worth reading first. But I'm just going to go straight to files, open that up, and there's my elephant. And you can see it's described as an STL model file, which is perfect for us. So I'm going to take that elephant from the zip file and put that on the desktop. Let's see if that worked. Yep, there's my elephant that I've just taken out of the file. So now when I come into Slicer, Okay. In fact, what I might do is shut this down completely and start again. I'm not going to save it. I'm actually going to go and start. The reason I'm doing this, I know it sounds weird, is I always prefer not to delete something that you've done loads of work on and then bring something else in. It tends to crash a bit. So I'm just going to open Slicer from scratch. Slicer for Fusion. I'm going to bring my elephant in. We'll go to OK. Go to Import. Choose my elephant, which I've just nicked. Open it up, and there's my elephant, ready for the same kind of treatment. And as you can see, it doesn't look particularly happy, but let's see if we can slice him. First of all, I'm going to choose the material I've already set, which is our plywood. Then I'm going to look at our size in millimeters. And he's 200 by 2. That's not too bad at all, actually. So I'm going to select my technique there. I'm going to go for interlocking slices. And it doesn't work at all. I think we'll need our elephant a little bit bigger. So what I'm going to do is ignore everything there. Go back to our sizes here. Make sure uniform scale's on. And that 200, I'm going to make 400. Enter. Much bigger elephant, I'm hoping. There we go. And now I can put more slices going across, because the slices going down this way are fine. But obviously we've only got a couple of slices going that way. And it says we've got 4 slices, which we have, because you can see it there. If I change that 4 to 6, and then enter. Now I've got 6 slices there, and I've got some legs, and I've got some ears, but they're not connected at all there. So we could probably get around that, but I'm thinking maybe we should put another slice in there. So instead of 6, I'm going to make that 7. Got an odd one. Okay, that's a little bit better. So let's try and deal with a few things here. I can see that the legs aren't right visually. What I'm going to do is I'm going to take this one, I'm going to move it. So I'm going to go to Modify Form. I'm going to take that slice there and just move it so it's in the center of the leg. I'll probably take this one and move that one out and this one out a bit, like so, just so it visually looks about right. Let's have a look at this leg as well. Let's take that in. It looks a little bit happier at the moment. But the ears are still a problem, aren't they? So looking at that, I think we might have to add maybe 1 or 2 more to get that in. So let's just see what happens when we move this one. And you can see there's got to be a bit that's probably a little bit better for us. Not quite working out on the ear front. So perhaps we need some more, or we could try twisting the model as well. I'm going to put some more in there instead of 7. I'm going to make that one 10 as well. And it seems to have crashed on me. Okay. Let's change it to a curve. And from there, change it to radial slices. That's interesting. Might put some more in there though. Still can't seem to change the numbers on the axis there, so I'm not quite sure what I've done wrong there. Just change that to by, and now I'm back. I think what has happened is the method to go to custom rather than by count. And when I've got by count, now I can change that. So I can change that to 10. Into that. I'm not quite sure how I managed to do that. So I might go back to our original. interlock slices. And I think what I'm going to try and do is get the something of an ear sorted out. Let's put a few more in there. Well, it seems like I picked a difficult one, really, isn't it? Let's move this one. I'm quite sure why they're not combining. Just doesn't seem to like it. Oh, okay, but you can see the point, can't you? We can actually take most things and get a good result. It's not actually worked out for the tusks either there. So I think I'm going to have to maybe play around with this a little bit longer. I don't want to bore you though, and we're almost getting to the point where I'd like you to have a go at this. So what I might do is go back to stacking slices. There, just to prove that we could actually make the entire elephant in stacked slices. And we can change the thickness of our material as well, because obviously it's going to use far too much material there, but that can be saved in any size. I can make it smaller. It's not a great model because obviously the tusks coming out there and the ears have presented a bit of a problem, but you can see the idea that we can take anything and get a result from it that could be created. I wouldn't suggest this at the moment because there's too much material to be used there. I'm just going to try going back to maybe the radial slices there and see if we can kind of change one or two things. And it may be worth just making it without the ears, printing the ears separately and just basically finding a way of actually gluing them together. But with a bit of time, I'm sure I could work that out. Just imagine though, if you made text, for instance, large scale, you could actually turn that into a set of shelving, that kind of thing. It really is amazing what's possible with this. I'm just going to drop that back from radial slices to interlocking slices again. And now I think I'll just play around with the slice direction. Okay, that's it. And you can see I can probably get quite a lot there. The tusks still aren't attached, but the ears, quite a lot of the ears are. That can then go to assembly steps. And we can look at that and how it's put together from the start to the finish. And as I say, I would probably have to make this a lot smaller and have to think about materials to be able to really kind of plan this so that it's kind of manageable. I probably end up looking at the size of this, just making it an awful lot smaller, I would think. So that's just kind of a quick demonstration. I think the first one was probably a lot easier. Let's just see where we're at. We're heading towards 8 o'clock. We've got another half hour, haven't we? So I'm just checking that I've covered what we've done here. Okay, so what I'd like to do with the next kind of half an hour, or next 20 minutes actually, is for you guys to pick something, to make something that you get something you've already done, or to pick something on Thingiverse and bring it into Slicer. Just have a play, and Owen and I will try and answer any questions, and at the same time I'll show you what's come off the 3D printer. So I'm just going to close this down.
Before you do that,
yeah.
Before you do that, once you've sliced an item, because since Ian's got this open and
oh, sorry.
Since he had it open and he could have showed you.
Get back to it.
You can take the sliced item and you can export it So where you open the file or import that file, there's a file tab, and you can export it as an STL file on OBJ. Now, Ian, I sent you via Google Chat a picture of that shark that I exported and rendered as green metallic thing. So, but once you've done that, once you have an exported mesh, you can then potentially 3D print that as a sliced object.
Yeah, I've done it before, and the problem with that is, oh, sorry, I can't get this back, I'm afraid. It's just really playing up and crashing on me. I'm just going to see if I can get out of this. Yeah, for some reason, Fusion basically just kind of threw me off there. I can't seem to get out of it. Just bear with me a sec. Yeah, the problem I had was that it does produce the model, but it produces in every single part of it is a solid. And to make it into a watertight model, I had to put it into Mesh Mixer and fiddle with it a little bit and make it into a solid, which we'll look into in session 5 again. There we go. I'm just going to take this off the machine. We've just finished, and hopefully I can just kind of grab inside it and just lift it up, because sometimes we have to get a scraper in there, and I think that's going to be the case as well. So what I'm going to do is set you a bit of a task, if it's okay, for the next 20 minutes. If you wouldn't mind, take your model, whether it's from the first session or something you've made today or something you grabbed from Thingiverse, and just practice bringing it into Slicer and start using some of that functionality, and just see what you can get. If you can save it as a PDF, you can send these to us, both either an STL or something you put through Cura, or a PDF from Slicer. What I'd like to do is, if you choose one, either a STL from Cura or a DXF or a PDF, I should say, from Slicer, and send it to Sophie, because obviously you've got her contact details. That's all going to go into one file, and then Owen and I have got 2 weeks where we can print everything and make everything. So you don't necessarily have to do it in the next 20 minutes, but if we just make a start now so you know what you're doing, and then maybe save something over the next week. So it's kind of, it's not so much homework, but it's something you can do and send to us. And if you need Sophie's email, we can put that in the chat as well. So if you want to make a start on that now and just shout out, I'll come back on as well so I can see the chat myself, and Owen and I will do our best to answer any questions. And round about 20 past, 25 past, we're just going to stop and have some questions and answers, make sure everyone's happy. So when you make a start with that, and I'm just going to get a scraper and take this model off the machine. If any questions, just shout out, because I can still hear you. So this is the print that came off the machine. I didn't design it, it was already on there. I would imagine it was just a test piece that Ben, my boss, used when he went to a school last, because we use this for kind of going visiting schools. You can see the brim is still on it, that's been placed, but I can just rip that off. And you can see quite easily that brim can come off. And a little bit of extra work if needed, just to clean it up. Very carefully, would use a knife on that. Or I think after that point, probably a little file or something, a tiny little file just to clean it right up. But that's pretty much the 3D print that we've made during this session. Okay, so hopefully everybody's working away. Does anybody have any problems? Somebody's asked if we can show how to convert that to DXF. I tend to do that in Rhino, to be honest, but we can also do it in Inkscape. We can bring a PDF in and we can turn it into a vector and then bring it out as a DXF. So I will show you that because our next session is 2D in sketching. So I'll make sure, I'll make a note of that, and we will take a PDF file and show you how that's done. So you can send the PDFs to us in the next week, that's not a problem. But I will show you that as part of the lesson next time. But I think we'll use Inkscape as it's free, and you probably got it. Just as a matter of interest, this machine, one of the problems I had is that the material was left in the machine for a long, long time. So I tend to do this anyway, just with this one, but I tend to take the material back out the machine every time I use it. And that way, it just seems to be indestructible. Every time you want to use it, it just comes through, it works perfectly. It doesn't get kind of clogged up in there. So I'm actually going to set that now to remove the material. And we go to change, press the button, and that's going to heat up now and withdraw the material from the print head. Yeah, we did have a real problem, Laura, with the same thing, that we couldn't download anything on the machines in the Fab Lab, and it was a nightmare. It's like you had to get permission from a grown-up to be able to bring something in. It was actually free, but amazing, you know, in terms of what you can do for students. So yeah, I feel you on that one. But if you can get Inkscape, which we will be using, I think that will probably solve any of the problems. The material's just coming out now. And there we have the material taken out. And for those of you who have 3D printers, I kind of recommend that if it's not used all the time. Our machines are always on, so we don't bother taking the material out. But this might not be used for another 6 months, maybe. With lockdown, it's probably been over 2 years before anyone's used it last. So it has been a nightmare to get working, but it is actually working fine. So I'm just going to go back.
And we always used to remove the material from the machine anyway, between uses, I think.
Yeah. Well, certainly with this, it certainly seems to do a lot of good. So I can turn that off now. And there we have it. It's not let me down again. Okay, just another 4 minutes or so, 4 or 5 minutes or so, and we'll bring this together with a bit of a discussion. Okay, so we're nearing the end of the session now. I just wanted to show you a kind of quick box that I made in Fusion, and the way that that was constructed. You'd think I'd be working with 2D drawings to produce the parts needed for this box to be assembled, but I didn't. I actually made it in CAD, in 3D, and I sorted out the thicknesses of everything, and it was that way that allowed me to actually plan this so that it actually worked. So this isn't actually glued or anything, it just comes apart. The idea is that on the inside is a bevel where a piece of glass fits. It's been designed. I think we've got we have to make 12 of these for a client. And then there's a piece of glass fits in there, the frame goes over the top and all gets glued together. But you can see the whole thing just comes apart and fits perfectly. And the reason it fits perfectly is because it was actually made in 3D. And what I did is I actually took a surface, which is a 3-dimensional thing in Fusion, and simply projected this onto the plane, on the axis plane. And that's what Fusion does really well. It will take that and project a line, which then I send to the laser cutter. So this is very, very complex stuff, but it's a similar kind of thing that we do with Slicer. But it is a good idea sometimes to actually, rather than do lots of drawings and hope it goes together, to actually make the thing in 3D and then take your drawings from it. I'm just looking at some of the, so we can make one 3D printed design and one Slicer design send you guys. So I was actually thinking, to be honest, of one, just one or the other. I was thinking about if we're inundated with too many, because we've got like 13 people online at the moment, 13 times 6 in terms of hours. You can see that's going to take a long time. So yes, I'm not going to say you can't do it, but we might actually print them smaller, as Owen said. You might set quite a lot at the same time. But send them through, and if it takes longer than the 2 weeks we've got to be able to get through the job list, then we will do that. We'll get all the way through them. And 59 minutes on a print is nothing, so we can get that, no problem at all. So yeah, I did say one or the other, but do both if you want to do both. It's just, we can't promise that we're going to have that, you know, within a couple of weeks or whatever. What I do want to do though is just go back to that idea of the object to be 3D scanned. It'd be really good. You don't have to do this, but it's really good if you want to have something scanned. If it is an object that we can just get easily, you know, if it's a piece of fruit or something like that, we can scan it. If it's something that you want to send to us or deliver to the main reception area, you could drop something off for us to scan. It's not something that's essential, but it'd be really nice if we're working on meshes and so on, and I show you how the scanner works, which I'm trying to still figure out. It may be something like this where we've got the scanner out, or I may film the whole process so I can kind of rewind and fast forward to parts. That might be a better way of doing it. But it'd be really good if you can cover 3D scanning online. That'd be quite a trick.